Hey, what's going on, guys? Let's do this problem right here. The question is asking 15 moles of nitrogen gas are placed in a 10-liter container at 100 degrees Celsius. What will be the measured pressure and what will be the volume left? So let's see how we can calculate the first part, measured pressure. And if you see this equation, this P, this is the measured pressure, and this total thing is ideal pressure. This is actually Van der Waals equation. This the whole equation is Van der Waals equation, and this represents the ideal pressure, and this part alone represents the measured pressure. This is what we are trying to calculate, right? So what we can do first, we can calculate the ideal pressure, and then from that one we can calculate the measured pressure. So let's calculate the ideal pressure first. So we are going to use the ideal gas law, that is PV is equal to nRT, and from this one I can find the P, that is the ideal pressure. So P is equal to nRT divided by V. We have all the information provided. Moles is 15, it's right here, and they have given the volume 10 liter, it's right here, and also the temperature is right here. So all we have to do is simply substitute all the values. Let's substitute. So 15 moles is the moles. Maybe I list this one in the side, so it will be clear. So N is equal to 15 moles, and then volume is equal to 10 liter, and we have the temperature in 100 degrees Celsius, but we have to convert this one into Kelvin. So this is going to be 100 degrees Celsius plus 273, that's going to be 373 Kelvin. So we have the Kelvin, and now we have everything. We can directly substitute these values to find the pressure. So let's plug these values. So we have 15 moles multiplied by R, that is here I am going to use joule per mole Kelvin. So there are different things you can use. Like one is with ATM, that is fine too, because that will give you the answer directly in ATM. But you can choose anything. So here I'm going to use this one, 8.314 joule per mole Kelvin. So this is our R, and the temperature we are going to use 373 Kelvin, and in the bottom we are going to have the volume, that is 10 liter. And if you calculate this value, this will give you 4,652,000. This is Pascal. If you want to convert into ATM, you can simply multiply this one by ATM and divide by 10,325 Pascal, and that gives you ATM. And if you calculate that one, that will give you 45.9 ATM. So this is our ideal pressure, but the question is asking to find the measured pressure, right? So this is this whole thing right here. So what we have to do to find the measured pressure, we have to subtract this part right here, this part. If I subtract this one, I can find the measured pressure. So to do that, I have to calculate this adjustment factor right here, AN square over B square. So let's calculate that one. Delta P, adjustment factor, that is equal to AN square divided by B square. So here we have to know the A for the nitrogen gas. So in the list we have these are the A values, this is B values, and here we have the nitrogen, that is 1.39 atm liter square per mole square. So that's what I'm going to use right here. So this is going to be 1.39 atm liter square per mole square, multiplied by the mole square, that is 15 square, 15 mole square. In the bottom we are going to have the volume, that is 10 liter square, 10 liter square, and that's all we have to do. If you calculate this value, this will give you 3.1 atm. So this is this value right here. So what I have to do to find the measured pressure, I have to simply subtract this one from the ideal pressure, that will gives the measured pressure. So P measured is equal to P ideal minus delta P, that is the adjustment factor, and here we have P ideal, that is 45.9 ATM minus 3.1 ATM, that will give you 42.8 ATM. So this is our measured pressure, and that is the first question asking, right? So we have found the measured pressure. Let's do the second part. So this is our A part, let's say this is A part, and let's go to the B part. They are asking what will be the volume left. So first of all, we have to know the volume occupied by the molecules. That is only this part right here, NB. If you calculate NB, that's going to give you the volume occupied by the molecules. So if you calculate that one and subtract from this total volume, that's going to gives the volume that is left. So let's calculate this NB part. So let's call this one delta B. Delta V is equal to NB. N is 15 moles and B for the nitrogen gas. So here we go, 0.391 liter per mole. So that's what I'm gonna multiply this one by 0.391, and that is liter per mole. And if you calculate this value, this will give you 0.59 liter, and this is the volume occupied by the molecules. But the question is, what will be the volume left? To find that one, I have to subtract this part from the 10 liter. So 10 liter minus, so let's say V left is equal to 10 liter minus this 0.59 liter. That gives us the volume left. So if you calculate this one, this will give you 9.41 liter, and that is the volume left. I hope you guys liked this video. See you next time.